Hello. Hello. So my name is Robert Simmons. I go by Utkonos, which is Russian for duckbill platypus. That's my handle. And I'm going to give you a talk about PlagueScanner today. So I'm a senior threat intelligence researcher. I work for ThreatConnect, just outside of Washington, D.C., in Arlington specifically. And I work on the threat intelligence research team. And that's my Twitter handle. Unfortunately, I couldn't get at Utkonos because someone in Russia already had that Twitter handle. So I'm malware Utkonos. That's an email address where you can reach me. So what is the problem that I'm trying to solve here? So let's say you have an unknown file from any source. It might be on a workstation in your enterprise. You might be doing research on some file that you found through your hunting process. You don't know whether it's malicious, but it's potentially malicious. And your goal is to scan it with as many AV scanners as possible so you can get all of the AV results and make a decision during your, what sort of response and just to get an idea of what the AV scanners think it is. So the first solution is to take the file and upload it to an online AV scanner bank. So this actually creates a problem where you've got a file that may be targeting you or targeting someone in your organization, and the file may have sensitive information in the file itself, and you wouldn't want to release that to the public, which you have no idea who it is that's going to be downloading or looking at the file once you've uploaded it to an online AV scanner site. So the second choice is to purchase one of the closed source scanner banks, and they are very, very expensive, prohibitively expensive. So I looked at these two choices, and I realized that there's a gap in open source software where open source would be the third choice, and this is the choice I've made. So I've created an open source multiple AV scanner framework, and this is a way that you can string together a large number of AV scanners and get results from all of them, and I've shared it with the world. So there's a few real-world use cases for this, and when I gave a talk on PlagueScanner at ShmooCon in January, a couple of the guys from the Veil framework said, if you look at your scanner, kind of think of it backwards and think, if I'm doing a pen testing engagement, a lot of pen testers will use malware that they want to have evade an AV scanner at their target company. So during their process of developing that binary, they want to be able to bounce it repeatedly off a lot of AV scanner engines until it's not detected. And obviously you don't want to do that with one of the online AV scanners because you're just going to give away the file, and chances are if your target is capable enough, they'll have a copy of that file coming in from the back end of some of those online scanner engines. Also, the second real-world use case that I'm going to get into in a moment, so this is from a defensive perspective, and you have, as I said earlier, you have a targeted weaponized PDF, and it has corporate data about your company. So I want to scare you a little bit and specifically talk about a weaponized PDF that I came across a few months ago. And this was actually a whole large number of weaponized PDFs. And this is the Ursnif malware family. Some of you might be familiar with it. So what it does is when it infects the workstation, it looks for other PDFs that you have on your drive and then infects each one of them. And then it does actually changes the file type to exe, but a lot of people aren't going to notice that. For me, that's an immediate red flag if something is pdf.exe, but some people might not notice that. And so you've got a weaponized PDF, and then you send it to someone thinking that you're giving them, a purchase order or whatever, and they then take that weaponized PDF, maybe it triggers their AV, and then they submit it to an online AV scanner site, and now, the internal data that you had in your PDF is now disclosed to the world, and that's, bad things can happen from then on. So I want to give you an example of this. It might not be easy to see it, but this is an example of ersnif. So this is a weaponized invoice. So someone took their BMW X5 to get repaired, and then they kept the PDF on their laptop. They got infected with ersnif. Ersnif weaponized the PDF, and someone, probably the person that they mailed it to, uploaded it to an online scanner site, and I got a copy of it. So this is an example of where this can go very wrong. And it can get worse. This is a packing list that I found, also ersnif. And then this is a check. I'm not sure why someone would scan a check and have it on their hard drive. It's not safe in the first place. But this is a weaponized check with ersnif. And so, where did I come up with the idea for this? Many of you, some of you may be familiar with this bar. This is at the Rio at DEF CON. And so 2 years ago, I was bouncing ideas off of some of the other hackers that I was speaking with about this gap in, where open source software could fill a gap with, AV scanners. And so that's where the plan came to fruition, and I've been working on it, for about the past 6 months seriously. And so there's a lot of components, and if you've seen some of my talks, this actually has been a sort of evolution where I've been trying different methods of getting the data in and out of AV scanners. Some of them cause more problems than others. But the current components on the left-hand side, so the whole project is built in Python 3. The core, I've chosen to run the core in FreeBSD, but you can run it on any system that has Python 3 and the proper libraries to import. I'm also running an Nginx, using Nginx to spread the file. So I was originally sending the file using FileMQ, which is a version of ZeroMQ for sending files across the ZeroMQ protocol. It was fairly slow. So what I've done to change that is I dropped the file into the web server, and then all of the scanner engine nodes come and pick up the file that way. And it caused a great increase in speed. I also use Python requests in each one of the nodes to pull the file from the web server. And then I use ZeroMQ to send the message out to each one of the scanner engines, telling it which of the agents to use, and also to scan it, and then the name of the file that it needs to scan. I use VirtualBox because it's easy. It has a couple of good components like page fusion, which is a memory deduplication. So if you have 5 different VMs and they're all running the same operating system, and they have a similar set of memory pages, the host operating system will only have one copy of that memory page, so it saves memory. Unfortunately, Page Fusion is not compatible with good old Mac OS, so I can't run as many scanner engines as I would like to on my laptop. But if you're running Linux or Windows, you can definitely use Page Fusion and VirtualBox. The output is JSON, so you can consume it. It's machine readable. You can also read it as a human. It's preferable, in my opinion, to XML because it's actually readable. And so on the right side, I've got the components that I'm kind of planning and working on still. So I want to change all of the agents over to a YAPC plugin system so that the person who's the end user of PlagueScanner, it's much easier for them to create a new plugin for a new scanner, and they don't have to learn as much or know as much Python coding. I'm also going to have a ElasticSearch report plugin so that the JSON document gets dumped into ElasticSearch. This is very important for some researchers because you want to see when a file began being detected and what it was detected as. So over time, if you take one file and you run the detection 1 week and then a week later, a few days later, the detections will change. And I found one thing that's interesting is that some AV scanner companies will have a very specific signature for a file. So they will tell you this is an Alena POS malware. Some of them, they'll have a very specific signature, and then all of a sudden the signature will change to a generic, or it'll just say it's Zbot. I've noticed a lot of things just kind of throw up their hands and say, this is Zbot, which seems to me that just a version of a generic signature. So I had planned on using Tesseract OCR and taking screenshots to get the AV scanner results out of some of the Windows scanners. I've abandoned that idea because it's very slow. And also last week, I was giving this talk at Circle CityCon, and one of the people in the audience turns out to be a Windows hacker from years. And so I'm not a very good Windows coder. And so I've been working with him. He's going to try to change the way that the data gets pulled out of the Windows-only scanners using accessibility features and other ways to hook the data and pull it out quickly at the time that the scanner is running, so that most of the scanners will finish at the same time and you'll get results without having to wait for OCR. So that's an improvement that's happened literally within the past week. So let me describe what it is that the components are made of. So it's your choice which scanners you want to use. I have a few plugins already, but the thing is, I'm not going to be responsible for violating any sorts of licensing and stuff like that. So it's up to you to buy the scanner, to use it properly, to get it licensed. Same thing with the Windows VM licenses. That is your responsibility. And then my responsibility is to bring the plugins and to make sure that they're instrumented properly so that you can get the AV results that you need out of them. And I have the goal of having at least the about 40 or 50 scanners. I don't have that at the moment. Right now, as of last week, I did a GitHub push out to out to GitHub with a set of agents, and I'm going to be pushing a lot more out either this afternoon or tomorrow. So keep an eye out for that. So what are the different types of AV scanner engines? So I've kind of categorized them. I used to have 4 categories when I started thinking about this back in January, but now I have 5 categories. So the first category is the obvious one, open source AV scanner, and I know you're all familiar with it. That only has one. It's Clam AV. And so category 2 are the types of scanners that are available in with a Linux or a BSD version. Those are very easy to work with, completely, not a problem at all. And then category 3 scanner is a Windows only, but it has a command line. And so you're able to use the command line and have it drop a file and then have it scan, and everything works out just fine. And then the 4th and 5th category, it's a Windows where there's a GUI only. And what I've noticed with some of these, some of the data that I need to get out of the scanner will be in the command line, but some of the data will be in the UI. So a good example of that is Windows Defender. So with Windows Defender, I can get the AV result, but the version of the scanner engine and the version of the signatures is only available in the UI, where you run Windows Defender, and then up there next to Help, About, and that's actually where that data is located. So I need to get that out with accessibility. And then there are some scanners where they may not use accessibility features. So this is actually an old slide before I dropped OCR, but what was the reasoning for OCR? It's for those scanners where I can't get the data out via CLI. I want to get the data out somehow, so take a screenshot and then run the screenshot through Tesseract. Obviously, that didn't really work very well. So what's the next option? It's Windows accessibility features. And so there's a component in there's a component in the Windows SDK called inspect.exe, and what it allows you to do is see where, what data is available in accessibility features if you basically highlight a UI component, and then in inspect it will show you the information available in accessibility features about that particular UI element. So this is the architecture that I'm using for PlagueScanner. So it's very simple. The center of it, I call it the core. So core is the submission, processing, and reporting component. There's the ElasticSearch output. And then the message queue here, so that's 0MQ, and the messages get sent at the time when you scan the file. It sends out the messages to each one of the agents, which lives inside of the Linux VMs or the Windows VMs. I had a question last week from one of the people in the audience, why do I have the Windows VMs inside of a Linux VM? And the specific reason for this is I'm keeping all of my project components and VMs in rack space, and there's no Windows 8.1 VMs available on rack space, so I have to have a Linux VM with all the Windows 8.1 VMs running inside of it, and then each one of those VMs has a NIC card running in bridge mode so that they appear to be on the same network as all the other Linux VMs. So there's some cool features in here. So page fusion, it deduplicates the memory across VMs, as I spoke about earlier. I'm very happy that I've gotten 0MQ working very well, and I have sort of my own protocol based on 0MQ. And so 0MQ is lightning fast. And also I've been able to use Python 3's threading so that I can actually send all of the 0MQ messages out to the agents concurrently and get the results back very quickly, so I don't have to go serially through each one of the scanner engines. And also ElasticSearch, because ElasticSearch is awesome and ELK is a great thing. So there's a lot of open issues here, and I would like to really specifically say the AV engines don't like to play well with each other. Sometimes when you install them on one machine, they look for them, look for their competitors, I would say. So what can I do about that? I'd like to get each one of the engines into a Docker container so that it's easier to install them and they can play better with each other. OCR, I'd still like to get it to fully function. So, if someone wants to help out and figure that out, you're welcome. One of the other components that I need to work on is daemonization. So I'd like to have the core running all the time. Right now, it's just a script. So you have a file, and then you run PlagueScanner against the file. It sends all the messages out to the agents. It drops the file into the web server. The agents pull the file, run their AV scanning, and then send the results back to the core. I'd like to have something that runs constantly so that I'd be able to have resubmission. So as you can see, resubmission automation, these two things are coupled together. And so the resubmission automation is good for, let's say you have a file and there aren't results, or there's maybe one scanner result. What I want to know is how long it takes for other scanner engines to pick that up, because they share signatures, and you might have something that's detected by one day, and then 24 hours later, a few more engines are detecting it. And so I'd like to know how long it takes and when those scanner engines get that signature into their signature bank. So the only way I could think of doing that is having a resubmission automation component, so that you could set a timer, maybe put something in a cron tab, something like that, so that it will run over and over, during a period of time, and then you can see the progression of the scanner results from one moment to the next. Also, I want to include HP feeds. I don't know if anyone's familiar with this, but it's part of the HoneyNet project, and so it's a way for it's a publish and subscribe protocol. where, and you might be familiar with this from Cuckoo Sandbox and also Thug. Both of those have HP feeds where the results can be sent back to a centralized HP feeds server. I'm still working on how to get the data from accessibility features, but the person who was in the crowd last week at Circle CityCon has been, I've given him a couple of scanners as examples of ones that are problems, and so he's going to be working on figuring out how to get the data out, which is awesome. I think, I don't know if I can call him the second member of the project, but I certainly hope so. So let's take a look under the hood of the project. So I want to give you a little idea of the code. After the talk, you can go look at it yourself. It's on GitHub. So this is the Nginx booster component, and it's also where the file gets the file's information gets loaded into the queue for threading. So I have the PlagueScanner configuration file where you tell it which AV scanners you have, and then what their IP addresses are. And so I loop through the config file and have an arbitrary number of AV scanners, and then it loads the IP address, the scanner engine name, and the file name that's generated by Python 3 named temporary file. So, and this is this is kind of an interesting part of it, where I drop the temporary file, and then the temporary file is sitting in Nginx, and then the name of the temporary file, which is a few random characters, is sent out as the file name to each one of the agents, and then the agents go and ask the web server, give me this file with this file name. So, and as I said earlier, I'm using threading. So this is the threading component. So I have a worker, and then the send to scanner is just the work that gets done. And so I send that function the scanner name, the IP address, and then the file name, and then it uses 0MQ to send that message out to each one of the agents. And so I actually have this set so that the number of threads are the same number of scanners that you have in the system. That way, all of them get their work started at the same time. So you have one thread per scanner sending the message out, and it actually works out very fast. Before I had threading in there, it was quite slow, and it had to wait for each scanner to finish before it would go to the next one. So threading has made a big difference with the speed of scanner results. So this is the file scanner component. This is the part that instruments the command line scanner in Windows world or in the Linux world. So I'm using subprocess popen and just feeding it the different command line arguments that are necessary for that particular scanner engine. And on this end, this is inside of the agent. This code is actually in the agent at this point. And I'm also using a temporary file here because the file, I don't want to leave that file laying around on the agent's file system. So I use name temporary file again here to create a temporary file. And one of the things that's great about name temporary file is when you close the file, Python cleans everything up for you, so you don't have to have a lot of extra temp files laying around and malware that's cluttering up your system. So, and then this is the core of the parser. So whatever that blob of that some scanner engine gives you, saying this is what it is, this is maybe my version. So this is how I just pulling it out using regexes to find the different components and data that I need. And so there's there's a set of parsers for each one of the scanners, and they're all slightly different. There's no regularity with the data that they give you when they run one of the command lines. So this is the message format that I'm using with 0MQ. It's very simple. I'm telling the scanner to scan, and someone was asking me, so if there's only one message at this point, why are you saying scan? But I'm actually planning on having more functionality depending on what the scanner is, and having additional functionality specifically to kick off an update. So many of the scanners have different methods for updating their virus definitions. And so I need to have a way to tell each one of them to update their virus definitions. And so there's going to be a message format update and then scanner, and it will tell each one of them, and then they'll have code for how to update themselves. Windows scanners are a little bit more difficult, I've found, because the update either runs on its own, so it has a timer where it goes and asks the mothership for the next set of virus scanner definitions, or there might be a button that you have to actually have your script click to get it to update. But all of the Linux-based virus scanner engines that I've worked with so far, they all have either a binary or a flag where you can have it update. So updating those is very easy. But updating the ones in Windows is a little bit more difficult. So this is an example of the exact message. So this is a specific message from Bitdefender. And so as you can see, on the right-hand side, that's the temporary file name that was created by the core. And that's the name of the file that was dropped into the Nginx web server. And I'm not married to Nginx. That's just my preferred web server. You're welcome to choose whatever type of web server you want. It's not really that important of a component. So let's take a look at a demo. So I recorded a demo so that I don't have to toy with the demo gods. So I've chosen a couple of different specific files here that are interesting, at least for me, and kind of demonstrate how you can use PlagueScanner and how it can be important in your processes doing research or defending a network. So these are the different files that I have that I want to look at. This is one that I was working on specifically 2 weeks ago. So this is teamviewer.exe, and I assure you this is not TeamViewer. So as you can see, this is not TeamViewer. Some of you may be aware of one of the older families of point-of-sale malware called Alena. I found that Alena is alive and well. It's being sent out. I've found it in our hunting process constantly for the past month or so. And so this is sort of one of their techniques that the gangs that are using Alena are using right now. They're trying to make it look like a tool, something like TeamViewer. Some of them were using sort of a log me in flavored bait email, and so they're making it look like something that an IT department would use to send to their users for remote help, and that's the way that they're getting the malware onto your enterprise. And let's look at another one. And actually, so this is one of the specific ones. I was really happy that Clam nailed Alena and didn't have just a generic signature. As you can see, Bitdefender just says Zeusy. This is the Zeus, Zbot, that sort of generic. I don't know what it is. Let's call it Zeusy. I don't know what it is. Let's call it Zeus. So that's just a generic scan. Let's look at the next one. So type faster. So this is, I renamed it sample.exe because even the file name of this one has information that I wouldn't want to disclose to any of you, because this is one of the weaponized PDFs that we looked at earlier. I'll pause it here. So it comes back as cryptic, DAZG Trojan, generic Trojan by Bitdefender, but this is actually specifically an ursnif and we saw versions of this sniff earlier. So this is the actual file, and this is the very good example of when you would want to use PlagueScanner rather than going and taking this exe and uploading it to one of the online scanner engines, because I'm sure many people in this room have access to the files that are coming into those online scanner engines, including myself. And so I don't think I would want my information in your hands, and I'm sure you wouldn't want your information in my hands, anything that's a corporate secret. So you definitely want to use something that's on, that you control every aspect of it. So let's look at another one. And this one's interesting because during your process of, responding to an incident, let's say, and you've gone out to, the workstation where someone has clicked on something, and you've recovered a malware binary from that workstation, and you want to know, what is the next step? What do I need to do or think about if I'm reverse engineering it, or if I'm doing standard analysis, if I'm doing dynamic analysis? What do I want to look for? So running it through scanner engines can give you a little bit of a head start on what your next step should be. So, for example, this one comes back as a dropper. ClamAV says Trojan dropper. These are fairly generic. These are generic signatures. However, what this tells me is that when I do a dynamic analysis of this binary, I want to look for another file. So a lot of malware families will do sort of a two-stage attack where the file that's attached to an email or the file that's part of a drive-by will be a dropper, and then that dropper, the folks that are writing those droppers and have that infrastructure delivering the dropper will rent their time on that system to different other groups, and so the backdoor or the Trojan that gets installed may be different depending on the week or who it is that has bought time on that. So I know in this case I want to look for another file, and I want to understand specifically what that secondary file is doing, what it is, what its capabilities are, and how it works. So this can shortcut your process of learning, getting some immediate information before you dive into further analysis. And this last one, so this RAR file, so a lot of things that we work with every day are detected as malware. The jury is out as to whether they are or not, but some of the specific things that we do end up being hack tools. So a lot of engines will flag something as a hack tool or something like that. And this is just an interesting way to see what it might be if it's just a random file that you've found. So this is the part of the demo that I had recorded, and I have a few more scanner engines that are Windows, and so I want to actually bring those up. This is going to be a live component. Hopefully this works well. So as you can see, this one, it's just two. I don't have a lot of overhead resources on this Mac, so just choosing these two. So I have Avast and Windows Defender, and let's see. So we've got three different samples here. The first one, destroy Sogu. This is an APT. File, and let's see what it gets detected as. And this is also something that I find interesting, that some of the signatures that I have, which are Yara signatures that I use during the hunting process, are very, very, very specific. I know that this is destroy, and I know it specifically because I've seen other versions of it. So it's interesting for me that I have such a very targeted set of signatures in Yara, but some things don't get detected as easily or as specifically. So as you can see, this one gets detected by Avast as Win32 agent AYPV. So that's interesting. I could just go cut and paste this and look online and see what Avast website says about this particular agent. And then let's look again. So this next one, I went ahead and put the name that that Avast is going to detect this as, but I know specifically this is a PlugX, which is an APT backdoor that's used commonly. So let's take a look at what it thinks this is. I'm kind of telegraphing what it's going to say because I put it into the file name, but so this comes back as VUPA, whatever that is, but it's actually a PlugX backdoor. Probably it's being used right now in an active APT campaign. It showed up in one of the online scanner engines. That's where I got a copy of it. Let's take a look again. The third one, so sample.exe. Again, this is a file where even the file name I wouldn't have wanted you guys to see. So we'll see what this one is. So this is another agent. So this is a specifically targeted agent. I'm not even sure what the family is, but this one is highly targeted and has corporate targeting information in the file. So this is another very good example of when you'd want to use PlagueScanner over uploading it. I feel like a broken record. Don't upload things that you don't know what they are unless you're unless you're working on something that's just your own private research. If it's something that's not like, you wouldn't want to do that in a corporate environment with something that's coming into your corporation, your enterprise. So let's go back to the presentation. So I invite you all to try it yourself. This is the GitHub page for it. There's a handful of scanners on there right now. Please, if you find any problems with it, please submit a pull request. If you can find a fix it. If you have any specific scanners that you want to see in PlagueScanner, please contact me. I'd be happy to take a look at them and add them. If you have any scanners that you'd like to write the instrumentation for, I'd be more than happy to have as many people as possible contributing to the project. It's just myself at the moment, so I'd be happy to have anyone add scanners and submit pull requests. And then I just wanted to point out, this is the blog where for my company where I publish a lot of my work. So please go check us out, take a look at the blog. We've got a lot of very, very interesting stuff recently, specifically covering OPM breach, and also we found one of the attackers who had written or was a user of the Rombertick malware family, which was in the news about a couple months ago. And so these are this is my Twitter handle, malware Utkonos. You can reach me on Twitter. I'm on there all the time, poking around on my phone. And also, this is the Twitter handle of my company, ThreatConnect, so check us out. And last but not least, do you have any questions? And if you don't know what that is, that's a baby Utkonos.